Okie dokie. Good afternoon, everybody. My name's Sung. I'm a program manager in Microsoft. I currently work in the SQL Server team. I'm a member of the Enterprise and Tier 1 Vector. Our Vector owns things primarily around the box product release and also around the Windows Azure virtual machine. So I in particular work on the SQL Server running in a Windows Azure virtual machine scenario. So that's what I'm here to talk to you guys today about. One of the features that we provide for you, if you would choose to run, that you are probably already familiar with, is always-on availability groups. And you can run always-on availability groups in Windows Azure as well, too. Have any of you guys actually tried this? Anybody? Anybody? One-ish? How many of you have used the always-on actually on-premise? Okay, good. So a good chunk of you guys are familiar with this already. Okay, so today I'll give you guys a quick overview of Windows Azure. I'll probably breeze through these slides, the first section, since this is the third day of the conference, and I'm sure you guys probably have heard a lot about it before. Then I'll go into what is specifically available on the virtual machines, on the IaaS space. Then I'll talk about some of the customers that we have, customer scenarios. I can't provide names, unfortunately, but I can go through some customer scenarios of how they're planning on using, how they're planning and how they currently are using Windows Azure virtual machines and SQL Server and high availability. And lastly, I'll briefly talk about some of the features that are coming up in SQL Server 2014 CTP2. CTP1 is released, but there's still some things coming in CTP2. So how many of you guys have used Windows Azure, just in general? Okay. Stop me if, or let me know if you want me to go through any of these slides in more detail. It was probably like about a quarter of you guys that have actually used Windows Azure before. I'll still go through these pretty quickly, though. So the concept behind Windows Azure, it's Cloud OS, workload mobility. It's based on being extremely flexible and provides you with both automation and levels of management that you could optionally opt into while still providing you full control over your own deployment because it's basically IaaS. It's basically just a virtual machine. The key principles for Windows Azure are highly applicable to running SQL Server in Windows Azure as well, too. One of the key goals here is you pay only for what you use. We recently announced a few weeks ago, we have per minute billing now. So you actually only pay for the minutes that you're using a Windows Azure virtual machine. And of course, you also get a discount if you're using MSDN. Windows Azure also provides you with a lot of automation tools. So a lot of it is heavily, you can script most of it. They provide heavy PowerShell automation and heavy PowerShell integration, which allows you to very easily scale up and scale down because you can just write a script. Again, this is something that you should be, you may be familiar with already. SQL Server also has a lot of PowerShell automation hooks, and so Windows Azure exposes all that for you as well too. And lastly, it provides you with very simple load balancing and managed availability through the infrastructure itself. And you can then achieve more complicated and advanced scenarios through using hybrid, which we'll talk about a little bit later. I'm just going to skim through this. This is basically just some of the entry points to get into Windows Azure. One of the key things I'll call out here is that we currently have 7 SQL Server images. Actually, that's 9 SQL Server images now, but there are 7 fully licensed images on Windows Azure. So this means that you can choose any of these images, and you can basically have a SQL Server set up running and installed within minutes. Probably anywhere between like 5 to 10 minutes of deployment time, and you actually have a full SQL Server instance going. We offer SQL Server 2008 R2, both enterprise and standard, and several other, we offer web, standard, and enterprise for SQL Server 2012. And we also recently released SQL Server 2014 CTP1 images as well. And we offer this on both Windows Server 2008 R2, Windows Server 2012, and recently, I think just last night, we released Windows Server Blue with SQL Server 2014 CTP1. So lots of options out there. If you want to really quickly start using some of the CTP1 features that are out there, this is actually one of the best ways to do it. I'm going to skip this demo. I'll show you the portal later anyway. I'll skip this slide too. This is basically just talking about some of the experiences with the data center and managing it. There's a Windows Azure guy who gave this part of the presentation in North America. So he went into a little bit more, and he talked about storage. I'll skip through this. Some of the interesting things is if you haven't seen what the rack looks like in our data centers and some of the concepts, there's terms such as load balance sets, availability sets, which I'll be using later. But these are basically within the racks. We set it up so that you can actually load balance your cloud services and load balance your virtual machines. And they also have this concept of availability sets, which is meant to provide you with higher availability. So if you have several virtual machines in an availability set, Windows Azure will try to not take down all of those virtual machines at the same time when it's doing service healing or patching and things like that. It'll try to keep at least a subset of those VMs up and running. And then there's a whole load balancer, which is actually pretty neat. It's kind of like load balancing as a service. So you don't have to pay for your own hardware load balancers. You can actually take advantage of Windows Azure to easily load balance some of your applications across several virtual machines. And I'll show you how you can use that with SQL Server as well too in an upcoming demo. There is these various virtual networks, which are really important for the hybrid scenarios. You can set up you can set up a site-to-site VPN. Using a site-to-site VPN, you have to provide a physical piece of hardware, a physical router that's sitting within your data center that then connects to one of our data centers connects to our data center through a gateway. And through this, you can actually join Windows Azure virtual machines to your own networks. And we actually support a whole bunch of different types of routers. We have generic VPN device support, so there's a lot of flexibility in how you achieve that. We also recently announced a point-to-site VPN. So this allows you the same benefits without having to go through that hardware route. And so this allows individual machines to then be able to connect into and create a virtual network with the Windows Azure virtual machines. And there's a few sessions. I'm not too sure if they actually happened yet. But if you're interested in learning more, the Windows Azure team actually has a few sessions on these virtual networks and these concepts. So the key takeaway are, you could build these kind of complex cloud services using both IaaS and PaaS. You only have to pay by the minute, and the second that the minute really that you stop a VM, you don't pay for it anymore. And you can also then leverage your existing MSDN subscriptions to get discounts or play with this in dev test environment scenarios. And again, the key thing here is it's really by the minute. There's no minimums, there's no rounding up. It's a really easy way to just get in and start using it, especially SQL Server Enterprise Edition. You can get in SQL Server Enterprise Edition. You only want to try it out for a few minutes. You don't have to pay for an expensive license. Just turn it on, play with it for a few minutes, shut it down, and you just don't get billed anymore. Or if you have an application, for example, that only runs for a few minutes, you can leverage this to actually achieve much lower licensing by only running that application for that exact span of time that you're using it. In fact, there's one customer out there who is doing this for a tracking system that they have, not the US government, but they build this system where at peak hours, they turn on their VMs for 1 hour spurts to collect data, and then after that hour, they just shut it down. So that they only have to pay for using it for that 1 hour. Okay, and then lastly, for MSDN, there is some discounts that you get for our rates, and you can also use MSDN products that you get through your subscription on virtual machines. And this again focuses on quick dev testing. So, to get into the meat of it, SQL Server high availability and disaster recovery scenarios on IaaS. So, there's three main scenarios that I'll talk about today. The first scenario is if you are completely running within Windows Azure and you want to achieve high availability. Windows Azure itself achieves 99.9% availability of their virtual machines, or that's their goal. If your application demands higher than 99.9%, you can use SQL Server technologies such as always-on availability groups to extend past 99.9. In fact, within our testing, we look at achieving around 99.95% of availability and higher through using SQL Server's high availability technology in combination with some of the Azure technologies. You can also do disaster recovery from on-premise to Azure. So let's say you don't want to pay for having this expensive disaster recovery site, or you don't want to have to maintain some other geolocated storage or geolocated compute, you can actually use Windows Azure to very cheaply and efficiently provide you that capacity by creating these hybrid scenarios. You can have all of your data, all of your compute, everything still running on-premise, but if some disaster occurs, have a secondary set that you can immediately fail over to running in Windows Azure. And so this provides you with a lot of protection from your anything that would affect on-premise at a lower cost than having to set up and maintain your own data center somewhere. And lastly, let's say that you are already within an Azure data center. You can achieve even greater disaster recovery by actually spreading your data or replicating your data to a second Azure data center so that you can achieve protection that way as well too. This is primarily for the compute scenario. For anything stored within Windows Azure storage, it is automatically already geo-replicated. But your virtual machines, for example, that you create, they're usually specific to a data center. And if you want your compute running with high availability, you may want to have this additional data center so that if there's anything that ever happens to our one data center, you can still have your compute running by simply failing over to a second data center. So let's talk about the first scenario. How can you achieve this? And why would you want to achieve this? So Azure's failure detection is good. It does provide you with a fairly high level of availability, but there are some things that it doesn't do, and there are some things that can go wrong. So at the highest level, it doesn't monitor SQL Server. So even though your virtual machines can be healthy, your storage can be healthy, it may not know that your SQL Server instance is down. So for that fact alone, you may want to leverage some of the SQL Server high availability technologies, at least to do that detection, to see if your instance is actually running or not. Secondly, if you actually, once you create a virtual machine, you own the virtual machine. So all the patching, all the maintenance, you guys still have to do yourselves. And that may cause downtime. So to get around that downtime, you may use something like an availability group to fail over to a second virtual machine, do any maintenance that you have to do on the first virtual machine that you were using, and then fail back. Or you may want to service the SQL Server instance yourself, so either the OS servicing or the SQL Server servicing. Azure itself, when it does service healing, something happens to that virtual machine, it goes down, it has some issue that occurs. What Azure will do for you is that it will automatically restart that virtual machine on a separate physical node. This takes about 12 minutes of downtime. So this is considerably higher downtime than if you were to use an availability group or database mirroring, where you can achieve a much lower downtime and much faster recovery by having that instance fail over automatically for you. Similarly, Azure's upgrade, so like the physical host, if there's an upgrade or a patch that occurs, it'll involve restarting that virtual machine on the same hardware. And again, you'll probably get around 15 minutes of downtime. So similarly, you may want to have SQL Server actually fail over by itself onto another running virtual machine. And again, if you actually are in an availability set, Windows Azure will guarantee that at least one of those virtual machines is still up and running. So you wouldn't be hit by something where all of your virtual machines are going down due to service healing or these upgrades that are going on. So what is it? So it's pretty simple. You basically have just two virtual machines running in SQL Server. You set up the availability. Failure detection occurs with the same failure detection that you're probably familiar with already. And failover takes seconds, usually. We support two types of technologies to achieve this today. We support always-on availability groups and also database mirroring. Database mirroring, of course, is kind of the precursor to always-on availability groups. Now, was there a question? Now, you may notice one of the technologies that's missing, which is failover clustering. So currently today, Windows Server failover clustering is not yet supported in Windows Azure. So it is only supported in a very limited scenario of using Windows Server failover clustering with availability groups. So only that very specific scenario is WSFC supported. Therefore, SQL Server failover clustering is not yet supported in Windows Azure. Okay. Availability groups provides additional benefits as well. This gives you really more control over your failover policy. As a lot of you may know, we introduced this new health monitoring in SQL Server 2012, which lets you specify at what point do you trigger failover. So of course you can use that. It gives you better granularity of what and when will trigger a failover of your availability group. It'll handle automatic page repair for you. So if there's page corruption, we'll detect that and take care of it. You can use readable secondaries, of course. So with readable secondaries, you unlock a whole bunch of scenarios such as backup and moving all your reporting workloads to the secondaries to move them off the primary. Excuse me. Improved management. So we've invested a lot in making sure that availability groups are easy to use, easy to maintain, easy to control. So you get all of those benefits. And of course, you can also use other features such as file stream and file table. It does require Windows clustering. So again, it does still require, I guess. So if you've used Always On, this is not news to you. It does still require it. But one of the main pain points we've always heard from customers was that Windows Server failover clustering was hard to set up. But the worst part of setting up Windows Server failover clustering was really the storage. And of course, this is exactly like on-premise always-on availability groups. You don't need to set up shared storage to use it. It uses completely non-shared storage. You still need a Windows domain and an Active Directory, since that's used to help control quorum and store other related information for the cluster itself. Okay? One of the key features for availability groups is the listener. Unfortunately, that's not supported yet. This is coming, and I think I believe that the Windows team and our team are working on supporting it within the next few months. So it should be coming shortly, but we don't have it available yet. They have a solution that they're coming out that's built on top of the load balancer and moving it around that way. And I'll show you the load balancer later, but the main problem why it's not supported is that they haven't implemented this whole floating virtual IP address concept yet. So they can't really have a single virtual IP address mapped to more machines. It's currently a technical limitation that they have. In the meantime, if you really want to use something that's similar to listeners, you can use database mirroring. Unfortunately, of course, that's limited to just 2 replicas, but you can achieve the same sort of behavior that you have with database mirroring. Using the failover partner keyword that was introduced in database mirroring. This failover partner keyword also works, of course, with always-on availability groups as well. But again, you're still limited because you specify the primary that you want to connect to and the failover partner that you want to connect to. You are limited to just specifying these 2 replicas. So if you have more than that, and if it happens to fail over to one of those, a 3rd or 4th replica, then the failover partner keyword in the connection string doesn't help you that much. But it is a workaround for now. So how do you do this? If you want to use always-on availability groups with Windows Azure virtual machines, it's pretty easy to set up. You have to make sure that they're in the same affinity group. Basically, they're in the same Azure cluster. This helps reduce some log synchronization latency because they're in the same cluster VNet. It's recommended that you set them up in the same availability set. Like I mentioned, Windows Azure has this guarantee that if you have these virtual machines in the same availability set, they'll try to keep at least some of them running. You do want to ensure, though, that they are in different fault domains, which means there's in different racks, and also in different upgrade domains. So these are slightly different concepts from availability set. But for example, if there's a power outage in a rack, there's nothing that the availability set can prevent. Right? So if you actually set the property that you want these virtual machines in different fault domains, then at least they'll be isolated from failures at the rack level. And similarly with upgrade domain, this will protect you from issues where it can potentially trump the availability set sometimes if there's a big upgrade that's going out. So if you have your virtual machines in different upgrade domains, it'll help protect against that issue from happening as well too. And make sure that, of course, these virtual machines are in the same VNet, because otherwise there's some DNS issues that may occur, and you'll hit some issues with Active Directory as well too. So the configuration of it, how do you actually go about in doing it? It's basically the same that you are familiar with today. So if you've ever walked through and created an availability group on premise, it's really the same concept. The only slight difference is that for Windows Server 2008 R2 and previous, there is an Azure DHCP bug, which creates duplicate IP addresses to the same cluster network name. So this obviously causes the cluster creation to fail, even though availability groups don't even use the cluster network name. There is a workaround here where you can go to this link, and the slides are available, so you can check this out at your leisure. But there's a workaround script that was written that you could run this script to actually create the cluster on your behalf, and it'll take care of all this for you. Alternatively, if you're using Windows Server 2012, this bug is fixed. So I happened to find that out last night because I actually had to set up a new cluster to actually do this demo that you'll see later. And I accidentally used Windows Server 2012, and I didn't have to use the script at all. And lastly, there's some tutorials listed here. So there's some links to how you can actually create it through either PowerShell or the UI. You can configure database mirroring also the same way. So this is probably even easier to configure because there's no net new external requirements besides the Active Directory controller and the Windows authentication. And if you actually are using a hybrid scenario, you can actually then use your own domain to achieve these prerequisites. So you don't, if you're purely in the cloud, you'll need to set some things up so you can enable this, you can enable the Windows authentication and having them talk to each other. But if you actually are in a hybrid scenario, you actually already are using your own domain, and then you can actually have them talk to each other more easily. The rest of the configuration is exactly like it is on premise, and there's a PowerShell tutorial for you to go to there as well. So let's see this quickly. Let me switch over. So what I'll show you now is, sorry about that. Move this down a bit. What I'll show you now is I created a cloud service called my name plus TechEd 2013. And this cloud service in Windows Azure contains 4 running virtual machines. The first one is used for another demo, so you don't have to worry about that one. The second one is the domain controller, and the next 2 are running SQL Server instances that are set up in an availability group. So you can see this here. You can see I've connected to one of the instances, and you can see that I've set up always on it. And it has 2 replicas, and it is replicating, or it's protecting this one database. And so you can also, you can also then run queries against it. What I did was I created a read workload, and I set up a load balancer between these 2 machines. So you see in this really simple script that I created, it actually attempts to connect to the cloud service itself, very basically. So I don't even have to specify a node. And it runs a really basic command. All it does is it prints out which server it's connected to, and it selects from a table. And then it waits a second, and then does it again, and it does it 500 times. So if I were to run this, you'll see that it begins connecting. And you can see it's alternating between connecting to target 1 and target 2. And this actually happens automatically. There's nothing else I had to do to configure this besides using the load balancer. Of course, this only works for your read workloads because your write workloads, you can't have them automatically go back and forth. So this is not listener support. This is just using load balancing. And because this is an availability group, I can do neat things like I can kill this secondary instance here. And this takes a while. The connection takes a while. Well, it takes a while to go down, first of all. But eventually, what happens is this instance fails. And you can see that here on the dashboard. So this instance failed. And you'll see this one ends up getting a connection error. But if I restart this, you'll see that the load balancer will target just the first instance eventually, once everything propagates out. But now that the first one is down, we can do interesting stuff. like add a few more rows to the table. And this is still running in the background. It's just, yeah, it still hasn't caught up to the fact that it's down. So let me actually just bring it back up. So what normally you would see is that it would just keep connecting, but it would just keep connecting to the one instance. But network latency, what can you do? So bring up the other instance, and I'll start this program again. So you can see, obviously, the first target one has the updates. You can see it's actually not hitting target 2 yet because it's still waiting on actually target 2 coming back up. But eventually, it'll actually start hitting target 2 as well. And because it's in availability group, target 2 will have resynchronized, and it'll be updated and also returning the same results as target 1. Eventually, this will happen. Sometime soon, hopefully. Does anybody have any questions while we're waiting for that to happen? Excellent. So you can see here, it actually already synced back up. It's brought back online. The load balancer is now distributing that client workload to both virtual machines again. And even though we inserted those 4 additional rows while the second virtual machine was turned off, we turned it back on, the availability group resynced it, and they actually both have the exact same data again. So there's a lot of really interesting scenarios you can achieve using load balancing as a service, and also, of course, with availability groups, not only for disaster recovery, but for instances like this, spreading out your read workloads. And the load balancer works automatically. So this actually will round robin the connections coming in to your secondary. So you don't actually have to do anything to achieve this. It's actually very simple. If you look at the portal, all you have to do to actually get the load balance working is you go to your endpoints, and you actually, when you create the SQL endpoint to allow connections into it, you can actually specify a load balance one. I already created the SQL one, so I can't show that one again. But you can see here I had another endpoint that I can now potentially select as a load balance. And then you create that endpoint, and that's it. The load balancing happens automatically. This takes time to show, so I won't demo it. But for example, if I had not created that endpoint, and I just started the connection, then you would see all of the connections first going to the target 1. Then I create the endpoint, and as the endpoint's coming online, you'll see target 2 starting to also be used as well. So it's very dynamic. No changes to any running applications, no changes to your SQL Server, no changes to any other configuration. You simply have to make this change in Windows Azure Portal, and you can achieve load balancing for your readable secondaries. Okay. So the next scenario I'm going to talk about is achieving disaster recovery between on-premise and your SQL Server and Windows Azure running and Windows Azure. Why would you want to do this? What's interesting about this? Well, there's a lot of reasons why your on-premise SQL Server can go down, as I'm sure you're aware. There can be transient issues, simply like, for example, your local area network had some issue, some gateway went down, your DNSs were not working incorrectly, and it could be fixed. Or it could be more permanent. There could be flooding, earthquakes, some disaster, some real disaster that occurred. Creating an actual disaster recovery site is probably pretty expensive. There's the cost to actually rent the physical equipment. There's the cost to rent the physical space. There's maintaining that equipment. There's maintaining that space. There's the power, the energy cost, everything that goes into it. Operating it, everything. So what does it look like? Instead of having to do all that yourself, take advantage of Windows Azure, and Windows Azure will provide you with a remote data center on your behalf. So you can have your on-premise instances, and in fact, you can actually have multiple on-premise instances, right? So you can actually have a primary and several secondaries on-premise, and then have this one secondary that's set up on Azure. So just in case if everything else goes down, you have that secondary in Azure. And of course, you can create multiple secondaries on Azure too. And SQL 2014 actually is increasing the limit of secondary replicas from 4 to 8. So you can actually really get a lot of replicas going if you want to. So what is this? As I mentioned, you can deploy one or more secondaries on-premise and also one or more on Windows Azure. And you can set them up to be syncing continuously. So you can still choose either synchronous or asynchronous. And you can also choose synchronous with your Azure replicas as well too, if you want to make sure that they're exactly up to date. You can choose whatever region to put your secondary replicas in. So there's a lot of reasons why you might want to choose a very specific region. Either you want to choose the one that's furthest away from you to ensure that there's nothing happening, or you might have some requirements, government requirements that say you must use a specific region, like you must host it within the continent or something like that. Or you can choose it simply out of latency. You may want to choose the nearest one to you so that you have lower latency from that connection. In fact, you may choose one nearest to you and add a secondary replica to it, and perhaps you then do a more remote one with an asynchronous replica. This is very low cost. You basically are just paying for the cost to run a virtual machine in Windows Azure and then additional cost for storage on top of it. You don't have to pay for anything else. No ops, no hardware rental, nothing. It's just the virtual machine, and you could do it per minute if you really wanted to. It'll fall behind on the data synchronization. You can do per minute and have asynchronous. It'll fall behind on the data synchronization, but it would also be cheaper for you. And you can also invert that too. So there are actually some customers that actually prefer to have their primary workloads running in Windows Azure for various reasons, right? Because in Windows Azure, you can scale it more efficiently. In fact, it's maybe even cheaper because you have to pay even less in terms of hardware rental and operations by hosting the bulk of your workloads and bulk of your applications in Windows Azure itself. But you may still want some ultimate form of security by having an on-premise instance. So you could also invert that too and have your primary workloads actually be running in Windows Azure, and then actually have a secondary replica that's set up locally. So if anything ever happens to Windows Azure, it will then actually fail over back to your on-premise site. So what technologies do we support for this? So we again support availability groups and database mirroring. And this is exactly like kind of what we talked about before. There's no major changes to it. The other thing that we support for this scenario is log shipping. You, of course, could use log shipping for the previous scenario as well, too, but it's not synchronous, and you have the potential for data loss. But in these cases, if you just kind of want an asynchronous backup or a low latency backup, you don't want to pay the cost of like maybe the transactional, the transactional overhead from using database mirroring or availability groups, you can use log shipping to achieve the same thing, and use log shipping to actually set up that secondary on Windows Azure so that it's getting the data backed up on your behalf. So again, these provide very similar benefits to the previous one. It's an integrated high availability and disaster recovery solution. So it's targeted specifically for your SQL Server running instance. You can again achieve, offline, or you can offload your read access into Azure. So this actually can be very powerful. So if you have, high performance write workloads occurring on-premise, you can keep all those workloads on your on-premise data center. And then if you have perhaps, lower performance requirements or, need to scale out your read workloads, you can then use these readable secondaries, put them on Windows Azure, and then redirect your read workloads all to Windows Azure to offload that from your primaries. You can also do various other things like migrate applications and run against run backups and such forth against your local secondaries as well too. Connect BI apps and things like that. And you can the other option, of course, is you can also offload your backups to Azure, which is something you could take advantage of to achieve some policy compliances. Like if you have to run backups every so often, rather than impacting your primary workloads, put that onto Windows Azure, create a readable secondary, and then have the readable secondary be performing the backup to meet the requirements that you have. And again, similar requirements as before. You need the Windows domain. You need an Active Directory domain controller. So how do you do this? You do this by configuring, like we talked about in the beginning, a VPN tunnel from your on-premise data center into Azure. You have several options for it. And these links provide you with some more information on where you can go and actually achieve, set up the hybrid scenario, and then join from on-premise to Azure or vice versa. And these have tutorials that walk you through all those steps. So this is what it kind of looks like. In our case, if this is on-premise, it would be in the Redmond domain. And we set up a primary with one secondary. The Windows Azure domain is external to us as well, too. So for us, we actually also have to set up a VPN tunnel if we wanted to do this hybrid scenario. So we set up a VPN device, it connects to the VPN gateway, and we set up a secondary replica. And I'll show you actually the setup later. I'll show you the setup coming up soon. I think next, actually. This is a single availability group, and data is being replicated across it. So I'll show you what it looks like. So you can see here, sorry, give me 1 second. So we have a setup where we have the two primaries on instance, and then we have the cloud replica, AG cloud replica. This is probably the fastest way to show it. So as you can see here, it looks similar to how it was before. All right, that's not as successful. Sorry, the magnifier is actually going a little crazy. But hopefully you can still see here, we have actually 3 replicas in this case. As I mentioned, there's the 2 replicas that are local on our local domain. And there's the 1 cloud replica that we've created. All right. Sorry about that. So this is the cloud replica. It's called AG Cloud Replica. I'll go back and show you what it looks like there too. But I wanted to also show you what the the VPN looks like as well too. So you can see here we created this virtual network called SQL Prod Virtual Network. It's connected through this gateway into Windows Azure itself, and there's several machines that are participating in it. And in this case, this is using the hardware setup. So we actually had set up the router and everything to have this connected. And so if you look at this high availability group, AG2, you'll see that there's actually the 3 instances running. All 3 of the instances, both the 2 local machines and the AG Cloud replica that I just showed you on the portal. And you can initiate failovers like you did previously on it. So and you can have them running and connecting to it. It basically looks the same as if it was either completely on-premise or if it was completely in the cloud. So. Now, the last scenario that we'll talk about is having disaster recovery spanned across several Azure data centers. So why would you want to do this? There's a few reasons why you may want to use SQL Server technologies on top of what Windows Azure provides. So Windows Azure itself, when you use a virtual machine, they have these X drives. These X drives look like local disks. They look for all intents and purposes as regular drives on it. But what they actually are they're actually blobs that are stored in Windows Azure storage. So Windows Azure storage already provides you with a degree of geo-replication and redundancy. So from that alone, even if you chose to not to use any of our SQL Server technologies, you actually are already protected to a certain degree by even just running the virtual machine and having your data there, because the X drive itself is protected. But the X drives and Windows Azure Storage doesn't guarantee write ordering. So there is a possibility if you're using multiple drives, like for example, you have one drive that's your SQL Server data files, and a second drive that you've attached that contains your log files. Those can potentially become out of sync as it's doing its geo-replication. So therefore, you may actually end up in scenarios where if you completely rely on Azure's geo-replication for some specific configurations, you may end up in certain scenarios where you are slightly broken. So therefore, you may actually want to use one of our high availability and disaster recovery technologies to mitigate against the scenario, so that you're always actually controlling the backup that you're creating. You may also want to use this if the current Azure disaster recovery SLAs don't satisfy you. In fact, there actually is not an official SLA for Windows Azure disaster recovery. So based on tests that we've done and based on feedback that we received, what typically happens is if you need to fully recover your VM, like that VM got trashed for some reason, it typically takes about 2 hours. And we see, up around 30 minutes of data loss if that occurs. So you may want a better SLO than that. You may want something lower and in the minutes or seconds range. So that would be a good reason to use one of our technologies. And you may want to actually just be able to test it. So you may, as part of your corporate policy, want to test out your disaster recovery. Of course, you can't really do that with Windows Azure. You can't really force a disaster to occur and have the geo-replication be brought back online and all those things. At least not easily. I'm sure you could call support and they could do it for you. But it's not easy. You may want to actually, or you may have requirements that say you actually test it out, in which case you can use, again, the SQL Server features to fully control that within your own environment. So it looks like how you would expect it to look. You have 2 Windows Azure data centers, so we're in multiple regions. Like in this case, this is using West US and East US, and you're simply replicating your data between these 2 points. We support 2 technologies that help you achieve this. The first, of course, is database mirroring. So you can, of course, mirror your database. You can mirror your database across these 2 locations. We also introduced this new feature called backup to URL. So backup to URL is available in both SQL Server 2012 and, of course, SQL Server 2014. And backup to URL, it allows you to, as the name implies, take a backup, and this backup is stored directly against Windows Azure Storage. So therefore, you have, if you choose to go the second route with backup to URL, you actually have several layers of redundancy. So your X drive would be geolocated and protected because it's on Windows Azure Storage. And then your backup, if you put your backup onto Windows Azure Storage, your backup then also becomes geo-replicated and highly available, and you have a level of redundancy. And you control the backup, of course, because it's a full backup set. So you don't have to worry about anything getting out of order or anything like that. And you can recover by restoring the backup. So what we don't support, unfortunately, is availability groups in this scenario. So availability groups requires that every single replica is part of the same Windows domain. And unfortunately, Windows Azure doesn't support sharing these VNets across the data centers also. Both of these things will change. So we are working with them, and they have had the feedback, and they are looking to implement these scenarios as well too. So in the near future, you should actually see this coming online, and we should start supporting it always on in these cross data center disaster recovery scenarios as well too. In the meantime, if you want, you can choose to simply use a single Azure storage disk that contain both your database and log files to kind of avoid some of that stuff. You can use database mirroring, or you can use availability groups with on-premise. So you can then get these cross data center by your on-premise being the one data center, and of course Azure being the second data center. And for database mirroring, you configure the public endpoint. The steps are exactly like configuring database mirroring today. except that you have to use the certificate-based authentication only, because obviously the Windows authentication wouldn't work across the data center since they don't support them being in the same domain. But you can set it up with the certificate-based authentication, and then have the two nodes talk to each other through the certificate, and then synchronize the data that way. So customer deployments. A question that we get asked a lot is, are there actually customers doing this? Are people actually putting their applications in these configurations that you've been talking about? So we'll talk about 4 companies today. And again, unfortunately, I can't talk about specifics or details about these companies, but one's a traveling firm, one's a car manufacturer, one's a video streaming company, and the last one is a healthcare company. So the first company, they're one of the leading tour operators in Europe, over 700,000 passengers as of 2011, 10 brands, 9 countries. They chose to implement an online travel reservation system on top of Windows Azure. So they had one data center on-premise, and they actually already are using availability groups today for their online travel reservation system. What they didn't have, however, is a disaster recovery site. So they looked at Windows Azure and thought that that actually was a compelling scenario for them to then extend their current availability and use Windows Azure to create their disaster recovery on Windows Azure directly. So they've created this proof of concept. It's currently working, and they're looking to go into production. I don't remember the exact timeline, but they're looking to go into production. They have a proof of concept that works. The second company we'll talk about is a car manufacturer. One of the biggest car manufacturers in the world. They actually have gone to production with this. So they created a car life portal. So this basically allows you to track your car. The car has metrics around, various things like oil, when you got your oil change, and miles driven, and when you should be doing maintenance. And also lets car owners to kind of socialize with each other. So they created this, and they saw that using Windows Azure was very cost effective for them to light up this application. So they actually hosted it completely in Windows Azure. They created an availability group with the primary and secondary, hosted completely on Windows Azure, and they went to production with this. Third company, they are an online streaming company. They actually also chose to use Azure as their primary. But they wanted a secondary for local HA in Azure, and they wanted another secondary which is kept in their on-premise domain for disaster recovery. This is the reason why they chose to do it is because as an organization, they've chosen the cloud and Azure as a big organizational strategy shift for them, as a ways to achieving better cost and achieving better control. So they have prototyped, they have a proof of concept of this, this configuration, where again, the primary and the secondary are located on the cloud itself, and then they extend the availability group to include a secondary on-premise, just in case if anything happens. I believe these guys were supposed to go into production in a few weeks on it, but unfortunately I don't have any updates yet on it. But this is a proof of concept, it is working for them, and thus far, as far as we know, they are planning to go and move into production with this deployment. The last company we'll talk about is the healthcare company. So this healthcare company uses both on-premise and cloud, and they currently are already using Azure as a hosting infrastructure. One of the key things here that's different from the other ones is they are bound by the HIPAA requirements, HIPAA compliance. How many of you guys have heard of HIPAA before? Okay. So semantic of it, but this basically governs some privacy of your medical records and stuff like that. So it's a strict requirement that they have to meet as a healthcare provider. So they actually chose to also use a primary on Azure. So they created something very similar. They created a primary and secondary in the cloud. And then for regulatory compliance reasons, they have an on-premise secondary as well too. But the thing to note here is that Windows Azure virtual machines actually have, Windows Azure itself has received several compliance certifications, including HIPAA, and Windows, of course, has previously been HIPAA certified. So using Windows Azure and using Windows, and of course SQL Server has also been HIPAA certified. So using this combination, you can still create applications that are that meet your compliance needs. There's a list of there's a list of compliance certifications that Windows Azure itself has met that's out there. I forgot to include a link to it, but it includes like HIPAA, ISO, and a few other ones. And of course, on top of that, you can add in the compliance certification that Windows has already achieved and that SQL Server has already achieved, and build highly compliant applications as well too. What's coming up in SQL Server 2014? So the big one that's coming up is Add Azure Replica Wizard. So to make it easier, we created this, this wizard that allows you to easily add additional Azure replicas into into Windows Azure. So if you're familiar today with Windows with the availability groups, there's an existing wizard for adding replicas. And what we did here is, so this is the same as before. You connected everything. Latency sometimes is an issue, especially for live demos. Okay. Let me kick this guy out. So this machine, unfortunately, this machine is actually having some, my laptop is actually having some connectivity issues, so it's for some reason not able to connect to that one, but it should be able to connect to the other one. So this is the existing Add Replica wizard that you may have already used. Hopefully this guy is able to connect. Otherwise there's not much of a demo. And what we added here is, you can see, in addition to the regular Add Replica, there's an Add Azure Replica. So if you click on this, this actually pops up this additional dialog. And I won't go through this because it's actually running. It actually takes some time. But this allows you to specify which image you want to use. So there's a bunch of images in Windows Azure Gallery that I showed you before. And you can also upload your own images to it. And you can specify the VM size, you can specify the VM name, and all those things. And this wizard will actually go ahead and create that virtual machine in Windows Azure on your behalf, join it to the cluster that you've specified, and also then, as part of the rest of this wizard, then finish setting up a replica on top of it. So this is a really easy way to actually add capacity, or add these secondary replicas into your existing deployments. You don't have to, you have a minimum of knowledge that's required for Windows Azure itself. You can do everything just through SSMS. You just have to know some basic login information, and then we will take care of all the rest of the deployment and configuration and everything for you on your behalf. So that's coming in SQL Server 2014 SCTP2. So unfortunately, that's not available now, but it will be coming soon. And if you guys have used the deployment wizard before, it's very similar to that. It gives you the ability to very easily create additional virtual machines without having to go through Portal, without having to do any of the setup and management of it. And you can it basically looks like an on-premise instance at that point. It looks like any other virtual machine that you've created on-premise. So there's a few additional resources here. You can read a white paper with these additional tutorials. There's additional links on creating the virtual networks and setting up domain controllers and things like that. And with that, that's most of the content. Do you guys have any questions? Yes, sir. Yes. You do. So the gentleman asked if with the Add Azure Replica, if I needed to have the network set up already. You do. If you have the network set up already, then the virtual machine actually looks exactly like another on-premise virtual machine. So in terms of all the permissions and everything, it's actually going through, for example, your domain. So there was a field there for adding the name of a domain user and things like that. So that domain user credentials would then be used to configure the failover clustering, to join that machine to the domain and to the failover cluster and stuff like that. So it does have as a prerequisite require that you actually have all that set up already and that you have these domain accounts that you can use to configure and set up the machine. But and then after that, the security is as if it's anything else on your domain. And the Azure permissions are handled by a certificate. So at the top of that wizard, there was an area for you to download a management certificate. So that management certificate will allow you to manage and create the virtual machine, and then everything else is based on your domain setting and credentials. Anything else? I think this is the first time I ended so early. Well, okay. Are there any other topics? So this is really powerful. If you guys want to talk more about it, I'd be happy to learn more. If you guys are interested in using it, we'd be really interested in hearing how you plan on using it and your experiences on using it. Whether or not you were able to achieve what you were hoping to achieve with it. So I would love to talk to any of you guys for more about any of that. Or if you have specific questions about how to set any of this up, I'd be happy to talk about it. Oh, yeah, sorry. It supports today. So, sorry. Yeah, sorry about that. So the gentleman asked, when is this support coming? It's actually available today. Sorry, I meant to emphasize that point earlier. But you can actually set up this full clustering, all those environments. And in fact, those 4 customers that we talked about, they're using released bits. None of that is using private bits, or none of that is using any CTP bits. Today, we actually have SQL Server 2012 and SQL Server 2008 R2 images. I mean, of course, you'll have to use a SQL Server 2012 image to use always on availability groups. But today, you can actually go into Azure, deploy several VMs with SQL Server 2012 on it, and set all of this up. So again, Windows Server failover clustering itself is only supported in that limited scenario of availability groups. It's not supported other things. But today, you can actually go and set it up and have this completely configured. In fact, I actually literally did this last night. I actually set up that first demo with the load balancer. I literally I used public images that got released. I actually used the Windows Server 2012, SQL Server 2014 CTP1 image, and created all of that. And I did it in literally a few hours, having that full setup, having the replication set up, having them communicating with each other, and having that going. So I was very able to easily create and deploy a full cluster environment in Windows Azure with stuff that's released today. Yeah, I really meant to emphasize that point, actually. Like, this is actually something that you, hopefully you get excited about and you go try it out. And again, with the per minute billing, this makes it easy to try out. And SQL Server 2014 CTP1 is one of our preview ones. So if you choose to use SQL Server 2014 CTP1, it actually is, you actually only pay for the compute. You only actually pay for the Windows Server. You don't pay for SQL Server at all. And we offer Enterprise Edition on it. So if you want to try it out, you can kick off some deployments, create a Windows Server 2012, SQL Server 2014 CTP1 build, pay only for the minutes that you're playing around with it, and try it out. And in fact, there's even a Windows Server Blue image that got released, and I believe we have a SQL Server 2014 CTP1 image on it. And because it's a Blue release, that one's actually also free. And of course, this 2014 CTP1 is free. So if you actually chose to use that image, then you actually can do it for free. The only downside, of course, is that that one's also like a kind of a preview release. CTP1, of course, is also CTP release as well too. So it's not fully supported, but if you wanted to play with it, all that's available. And if you actually wanted to go to production, again, like I mentioned, these customers, they actually are going into production with our released images and with our released bits and binaries. So there's nothing new there. I mean, one of the customers is actually waiting for listeners, but and we did provide private bits for the listener support. But other than that, they're using public bits. Any other questions? Okay, well, thanks a lot for your time. I hope you appreciate it.